The atomic theory, part one. Part one. We're going to be looking at all of this, just section down. The first thing we're going to look at is theories of matter. So we have some theories of matter that are continuous. That means matter can be infinitely divided in half. You can just break it down, break it down, break it down, keep on breaking down. It will never end. But then you have some that are discontinuous, saying that matter is composed of tiny individual particles. If you remember from last time, the end of last unit, what we talked about, matter. Matter could be broken down. Its simplest form, we said, was atoms. We're going to get to how we discovered that. First off, you have this dude called Democritus from 400 BC. He came up with the 4 fundamental substances: fire, air, water, earth. And it supported the discontinuous theory of matter because matter is composed of individual particles. What particles? Well, you have fire particles, you have earth particles, you have water particles, you have air particles, and they should not combine. So he also termed atomos, and because in Greek, A stands for not, and tomos stands for cut, not cut, uncuttable. So with this uncuttable atom theory, if I have this red atom or suitcase and then a black atom suitcase, I can't break them down. So this red atom weighs 2.5 pounds. This black atom weighs 7.5 pounds. They can't get broken down anymore. That's it. That's as far as they can go. That's what we can get from his theory. So looking at the law of multiple proportions, we can find out what each one weighs, if that makes any sense. So if I know it's right here, mass of the oxygen combines with 1 gram of carbon. So I have 1 gram of carbon and then the oxygen right here. I can determine how many grams of oxygen there are. So looking at this, I've got 0.33 grams of oxygen. I have 0.66 grams of oxygen. Because I know there's 0.66, I know this is 1 CO2, or sorry, CO. This one should be C2O2, because there's 2 grams and 2 oxygens. I'm sorry, this is a typo. All right, compound A. Looking at this, we've got nitrogen and 1 gram of oxygen. So I know there's an O here at least. These ones get a little tricky. So I have to go based off of that. And I can find these compounds. Don't worry too much. We'll keep going a little bit later. All right, so the next dude up, we've got Dalton. He's from 1803, and he came up with the theory of atoms. Not the word atomos, but the theory of atoms. And that elements are made of tiny, invisible particles called atoms. Atoms of a given element are different from other atoms of different elements. So each one is different, remember, from the reading? And then compounds formed when atoms are chemically combined together. A compound always has the same number and same types of atoms. So it's a ratio. Atoms are not changed in a chemical reaction. They are reorganized. Very important. We're going to see that later. So this is Dalton's model of an atom. It's just one sphere. That's it. That's his theory. Looks like a ball. Then you have Thomson. In 1904, Thomson studied the discharge in cathode rays. He found that high voltages cause metals to produce streams of particles that are repelled by negative plates. And it's kind of like a magnet. You've got positive ends and negative ends. The positive wants to match up with the negative. Negatives rebound off of negatives. So he found, because he was testing that, that particles were present in all metals, and that there's a negative one. Because if he has a negative end and it's like shooting off away from it, it's like, no, I don't want to be there. It's like a magnet. you have two negatives, so there's got to be a negative in there. There's got to be a negative particle in there called the electron. So as you can see, here's the cathode, here's the anode. That's that negative plate. And the negative particles bend that light away from that negative plate. Now, if they were positive, it goes straight at that plate. Oh, sorry. And you did see right down here, you have a positive plate. And he had the plum pudding model. So that just looked like there was that ball, Dalton's ball, but little negative particles all over in it. And we're going to jump to this. So we're looking at this. This is a cathode ray tube that you can see right here. He's got a positive and a negative. He's going to turn it on. So when he turned it on, you can see that the ray gets deflected a little bit. And look, as he puts the metal down, that magnet down, the negative end, it is bending. It's literally bending it, which I find is so totally cool. He bends that light down, right? So if he flipped it over and did the positive, it attracts that light because the negative wants to go towards the positive. Enter full screen. All right. So then we have Milliken's oil drop experiment. We haven't looked at that too much yet. So with this, this guy suspended charged oil drops in an electric field. He discovered that the elementary charge carried by one electron. He found out what that charge is, and he calculated the mass of an electron. It's really, really, really tiny. Rutherford, the guy I have the issues with. So Rutherford, in 1911, he and his group performed an alpha scattering experiment to see how the positive and negative structures were arranged in an atom. You already saw the plum pudding, where you just had the ball with some positives in there, but there were negative balls just all over it. So they didn't know yet that there were positives in there, or they kind of guessed that there was, but this is a way that they found definitely was. They used this gold foil. So they shot out an alpha particle at a gold foil. And they noticed, you know, if it's a plum pudding, you got all this stuff in the way, it should bounce off, right? Well, instead, they found some shot straight through. Like it just like went and hit these reflective thing, which actually lit up every time one of the alpha particles hit it. And they found that when they shot it out, it automatically got diverted sometimes, and it hit the side. It didn't go straight through. Like they thought it was, the whole time they thought it was going to go straight through. Pardon me, I made a mistake just a second ago. They thought it'd just go straight through and be done, and that's it. But that didn't happen. What happened was it got deflected. And they were like, okay, what's going on? Well, what did that figure out? These gold particles had something there that reflected, like it hit off of something of the alpha particles. Since most alpha particles pass directly through the atom, they found out that it's mostly made of empty space. But because a couple got deflected, they found that it had this dense nucleus on the inside, which I think is kind of cool. So his model kind of went a little bit further. You still have that ball, you still have the electrons, instead of being all over the place like plum pudding, they're spinning around this central thing in the middle. All right. So next, once you're done with this, we're going to go to the next one. And if you have any questions, please let me know.